So in this video, we're going to be discussing some of the concepts presented in section 1.4, mainly dealing with segments, and then actually the angles we'll pick up in another video. So we'll talk about segments, we'll talk about segment addition, midpoint, and midpoint formula, and stuff of that sort. Okay, so we're going to start by reviewing some algebra regarding absolute values. Okay, we know that absolute value means do the operations contained within the absolute value bars here, 5 minus 3, 3 minus 5, and then strip away the sign of your answer. So as we know, in either case, the final answer is 2, of course, because the absolute value is eliminating the sign. Okay, so as a generalized rule, based on that example, for any two values, the following must be true. The absolute value of A minus B is equal to the absolute value of B minus A, as demonstrated here, and as you can demonstrate for yourself with any two numbers. 18 minus 20 is negative 2, but its absolute value is 2, the same as 20 minus 18, absolute value. So with that, we were able to compose what's called the ruler postulate, which is it implies the following. We'll go over that. Okay, basically what we're saying, if you have a segment, okay, whose endpoints are located at A and B, and that segment can be put over top of a number line, such as what we see here. In this case, A is at the position at the coordinate of negative 2. B is at the coordinate 3. So intuitively, you would say, well, that looks like a distance of 1, 2, 3, 4, 5 units. And indeed it is. But, okay, if we simply said 3 minus negative 2, well, yes, that gives you a 5. But negative 2 minus 3 gives you negative 5. So what we have is we're taking advantage of this rule up here. Okay, again, the ruler postulate as stated here. Points on a line can be put to a one-to-one correspondence with the real numbers so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers. All that is saying is applied to this particular example, A at negative 2, B at 3. Therefore, the distance, the length of segment AB, or the distance from A to B, is, by formulation, absolute value A minus B, that is negative 2 minus negative 3, absolute value. Please don't make mistakes with your operations down here. The sign numbers can be tricky, but they shouldn't be at this stage, okay? So at any rate, here we get negative 2 plus negative 3 is negative 5. Its absolute value is 5. Or if you prefer, the B minus A absolute value, which is 3 minus a negative 2. Minus and minus goes positive, so that goes to 5. Either way, okay, our final answer is 5 units. Okay, let's move on. All right, now we're talking about segments which are congruent. Now, these segments have simply been sketched on Sketchpad, all right, and just by their appearance, we know that they're congruent because of the little hash marks here, okay? So the little hash marks here are implying that the segments are congruent. This reads, the measure of the segment AB is 6.1 centimeters. The measure of the segment CD is 6.1. Therefore, the two segments are congruent, okay, and we can use this little congruent symbol here, which is the equal sign with the wave across it to imply the congruence. So that's reading segment AB is congruent to segment CD because they have equal lengths. And even if it's never told to us, if the picture shows two segments, even if it has a third segment in here, which has the same hash mark through it, then that's implying that they're congruent segments. If I had another two sets of congruent segments, say X, Y, and PQ, which were 4 centimeters, in the same picture, then I would use a double hash mark for them. You'll see that. Okay? Segment addition postulate, very important idea. Let's get the picture up here first, okay? So what we're looking at is, you might say, oh, this is a line. But all we're concerned with is this portion of the line of the segment, PR, all right? And it could be PR, it could be AB, it could be any 2 letters with a third letter in between. In this instance, the 3 points are collinear. What's that mean? It means they're all on the same line, okay, as shown in the picture. And this is a rather intuitive idea. Simply saying if you take the 2 pieces, it equals the whole length, all right? PQ length plus QR length is equal to the entire length PR. Okay, we could use the segment symbol over top. We could use the measure as we did in the previous slide. Okay, it's all understood the same idea here. As an extension of this, if there was another point here, S, okay, then of course then the sum of the 3 segments would equal the entire length, and all other kinds of possibilities. Now comes the time we put a little bit of algebra to this. Here's how the problem would be posed to you, okay? And there's no picture, so we'll give you the picture, but it might be that there will be no picture provided. So either you draw the picture or you see it in your head. It's not a bad idea just to get in the habit of drawing whatever is described for you here. So, so here it is. So we draw this, which is the condition, some segment, and G is in between them. The length of EG is labeled as 6x minus 5. The length of GH is as 4x minus 6. And the entire length of EF is 129. So I simply put those in there, and lo and behold, I can apply my segment addition postulate, which says that EG plus GF is equal to the entire length EF. Having that stated, I now have an equation. Okay? We all know how to solve equations. We link our like terms together, our x terms, and our number terms that come down to this statement. We solve for x equals 14. Okay? Now, we are finished because all the problem they ask for is x. But in some instances, they ask you to go a step further. And I might say, okay, well, find what is EG or what is G8 and GF. If you just leave it at x equals 14, then you're not answering the question. As I said, in this instance, we're answering the question. But let's put that in anyway, because EG is 6x minus 5. With this x value in, we get 79, okay? And with the same x value going in for GF, we get the 50. And of course, the 50 and the 79 combines to the 129, whether that's inches, feet, it really doesn't matter, okay? That we've answered the question and we can move on, okay? Now, the notion of a midpoint can only happen on a segment because it has to be something which is measurable. There's no such thing as the midpoint of a line. I don't ever want to hear that. So we're going to say here's some segment where C is the midpoint. Well, obviously, okay, the segment addition postulate still upholds. AC plus CB is equal to AB. But furthermore, okay, we know that from C being the midpoint, that it divides the segment into 2 congruent segments, mainly AC and CB. So we can make that statement, okay? Even had this information not been given to us, if we had the single slash marks or paired double or triple slash marks in here, we could make that conclusion, this conclusion. Segment AC is congruent to segment CB. Another algebra problem of sort coming our way. Okay, in this instance, we're told, okay, AC, that's the half length, is given 2x plus 1. CB, which is the other half, is 3x minus 4. So we're asked to find all 4 lengths. So we start . Okay, so we resume. From this, we know that the two segments are equal, they're congruent, so we set them equal, and we have the algebraic, this statement that 2x plus 1 equals 3x minus 4. Okay, there's a little algebra, and move all the letters to one side. Okay, all the numbers to the other side. So here we can simply see it's easier if we just subtract 2x from 3x, giving us 1x, and add 4 to this side, giving us 5. We are not finished because we were not asked to find x. We are asked to find, okay, the lengths of the three sides. So we throw these values back in for x here. There's really no need to go any further because if one is of 11 units of length, certainly the other is, and certainly when we add them together, their total length is 22. So that is the end of this slide.